Okay, so this is a lovely little identity that we're going to have to prove. Don't let these things intimidate you. Sometimes they look scary, but they are actually not so difficult. I think this is one of them. They're not as bad as they look. What I usually recommend we do is grab one side, the one that's more complicated, and simplify it. And so it would be a good question to say, this one looks, I don't know, more involved, but actually I think this is more complicated because cotangent squared is a fraction, cosine squared over sine squared times another angles, cosine squared over sine squared, which is a fraction very much like this, well, simpler, but then minus 1. The last thing we do here is a division. Here we have a complicated fraction minus 1. And you know, with fractions, addition and subtraction are actually more involved than just a plain division. So I would say, let's mess with this side. Let's grab the right-hand side. And that's cosine squared alpha divided by sine squared alpha times cosine squared beta divided by sine squared beta minus 1. And then always keep an eye on, this is where we want to arrive. And if you look at the denominator, it's already set. So that means we probably should just bring stuff to the common denominator and massage the numerator because the denominator is already in the shape we wanted. So we have sine squared alpha times sine squared beta. And the numerator is cosine squared alpha times cosine squared beta. And if we bring this to the common denominator, so we rewrite one as sine squared alpha, sine squared beta over itself. So the denominator is in the form that we want. The numerator is, this looks way too much in degree, and these are products that somehow need to be collapsed down. Cosine squared alpha, that seems to be all right. Sine squared beta, that seems to be all right. So I would first do something about this. So let's just try and rewrite it. Rewrite cosine squared beta as 1 minus sine squared beta, which is pretty basic. It's just a Pythagorean identity. See what shakes out. The second part should be just a minus sine squared beta. So let's rewrite that too. So let's rewrite sine squared alpha as 1 minus cosine squared alpha. And let's leave alone sine squared beta. Why did we make these decisions? If you look at this, cosine squared alpha is something we want. So we're not touching that. But cosine squared beta should somehow be gone. So one way to maybe initiate that is to rewrite it using the Pythagorean identity, which leaves to mind since this is squared. And then similarly, sine squared beta is something we might want to leave alone and then mess with the other stuff there. All right, so let's see what that does. So we just distribute. We have cosine squared alpha minus cosine squared alpha sine squared beta minus 1 times sine squared beta is sine squared beta. And then minus times minus is plus cosine squared alpha sine squared beta. And actually, we're kind of getting lucky because if you see these two cancel out each other, do they now? Sine squared alpha sine squared beta. And not only that, but what we're left with is exactly, we're there, right? What is left is what is the other side. So we're done. This is just cosine squared alpha minus sine squared beta divided by sine squared alpha sine squared beta, which is the left-hand side. So it wasn't that bad after all. Thank you for watching.